and some solutions I've found. I've been working with a number of biodiesel producers, both big scale, the 30, 100 million gallon plants, as well as the small 100 gallon plants. So this is a compilation of some of the solutions that I've found and gives you an idea of where to look in the biodiesel process to find out where the problem is and how to address those. A little bit about myself. I'm a chemical engineer with an MBA. I've worked in the biodiesel industry. We developed a workshop that at Iowa State University and cooperation with the University of Idaho. John Van Gerpen, myself, and a number of others got together and put together a workshop that we've trained people, and all the information we teach in our workshop basically can lead to some of these solutions. First thing, here's the basic esterification reaction. As you can see, a triglyceride with methanol. You add a base catalyst. You get a mixture of fatty acid esters and glycerin. Now, any problem you have in the plant falls back to this equation. So you have to understand the technology behind what you're making to at least understand where the problems might be coming into the reaction process. Quick mass balance: for every 100 pounds of oil, you'll make about 100 pounds of biodiesel. You use 22 pounds of methanol because you have to add an excess to drive the reaction to completion. And then in the final product, you'll have 11 pounds of glycerin and 11 pounds of excess methanol. So if you add the exact amount, only 11 pounds of methanol, it's going to take a lot longer for your reaction to take place, and it probably won't go to completion. Now this is just a rough schematic of what a process would look like, and I've labeled them. If you say, geez, I'm making bad biodiesel, where should I start to look? Well, the first place to look at your feedstocks, your oil, your methanol, your catalyst. What's the purity level of those items going into the plant? I'd say a good portion, 75% of the problems in the plant start in the feedstocks. Then the second place to look at is your reactor. How are you running your reactor? Is it running to specifications that's going to make good product? Then the next place for these problems to occur is in the separation. There's a lot of different methods, whether it's centrifuge or settling. Those can all add to some of the problems that you're going to see downstream with your product. Then the fourth place is how you're going to clean your biodiesel. How you're going to remove the impurities. Then the next place I would look is say, let's look at the methanol. If you're recovering your methanol, that's a place where a lot of people have problems because they're bringing water back into the reaction, which is killing the reaction. And then the final place would be how you're neutralizing the catalyst and how you're removing it. Some common problem areas. Most of the time when someone calls me up and says, hey, we're having a problem, it's in one of these four areas. It's either low process efficiencies, they're not making as much biodiesel as they thought they would. They bought somebody's technology and they said, you're going to make 5 million gallons of 5 million gallons of biodiesel a year, and you're not making that much. So there's the problem with the plant not running at the capacity. And then part of the problems are biodiesel isn't meeting the specifications, which is important if you're going after any government incentives. There's a liability issue. And I'll cover all these in a little more detail and show you where some of the problems are and some of the solutions you can find. Inconsistent process control. If you're always making adjustments to your plant, something's causing it to, you have to make a constant change. And usually those constant changes make product because there's a lead lag factor and you make a change when it's going to actually show up in your product. And then problems running different feedstocks. If you were to run virgin soybean oil all the time, you probably have very few problems. But most people aren't. They're running whatever cheap feedstock they can get, so that's going to lead to problems, and that's one of the problem areas. Let's go through a solutions checklist. Okay, if you come to me and say, hey, we're having low process efficiencies, we're not running at the rated capacity, first I'd look at is it long reaction times? And that could be due to insufficient methanol. And it could be because you didn't add enough methanol in the first place. You're trying to skimp down and add minimal amount of methanol. Or you could have losses to high temperature. A good example, someone was raising up their reactor to a higher temperature, they had a vent on the reactor, and the methanol was just boiling, going out into the air. So if you're going to run right at the boiling point of methanol, which gives you the quickest reaction time, then you should have a condenser that brings that methanol right back into the system. Otherwise, you're going to lose the methanol, you're going to change that balance, you're not going to get full conversion. Could be due to insufficient catalyst. Well, what happened to that catalyst? If you sat in on the first presentation earlier today, they talked about free fatty acid that steals your catalyst. It'll make soap. And that'll make your catalyst disappear. So it could be too much FFA. And a lot of times people say, well, I checked, I titrated for the FFA, I know how much extra catalyst to add for the FFA, but then they don't realize they're creating FFAs in their process, in the reaction, which is then stealing catalyst, which is then taking away your catalyst to make the reaction go to completion. And impurities in the feedstock can cause side reactions. A good example is I had a manufacturer who was making gelatin and taking stuff off of pig skins. And they had an oil residue that they had left over. And they wanted to sell that to biodiesel producers to make biodiesel. They were initially applying it to the land or selling it to the waste treatment plant so that they could grow their bugs. Well, I took some of their oil and I ran it through biodiesel. I did a test lab making of biodiesel, and I couldn't get the amount of conversion I was expecting. I was saying, well, what's going on? Why aren't we getting this? I checked the FFA, I checked everything out, and it turned out that there was a protein in that oil that was grabbing that catalyst and stealing it away and making some organic complex protein that was taken away and keeping it from aiding in the reaction. So then I went back to the company and says, hey, do you know about this protein? They said, yeah, we can control it somewhat. I said, well, if you can reduce the amount of protein in your oil, it's going to make the oil much better for making biodiesel. So they attempted to change their reaction to make better product. Some other things that could lead to long reaction times is temperature's too low. If you run right at the boiling point of methanol, just below, then you're going to get the fastest reaction time. If you run it at room temperature, you're still going to get a reaction. You can go to completion, but it might take you 8 hours as opposed to 15 minutes, 20 minutes. So, you have to consider that is how, where's the temperature, what temperature you're running at. Could be improper mixing, and that could be either too much mixing or too little. Part of the problem with there is initially the oil, the methanol, and the catalyst don't want to mix together. So you have to really beat the heck out of it, shake that bottle up a lot, whatever you want to do, but you have to mix it up very much to get that to start to mix together. Once they start to mix together, then they start making glycerol, which then helps, glycerin is like a nice go-between. It acts like a surfactant. It'll help bring the oil, the methanol, and the catalyst together too. And it starts reacting around the outside of the glycerin molecule. So that'll start improving. So once you get it moving, you don't need as much agitation. If you continue to beat the heck out of it, well then all of a sudden you're getting soaps made. You're also going to start getting emulsions. So that could add to problems that you're not getting complete reaction because things are turning into soap and you're getting a jello. So you want to make sure that you have mixing the right amount at the right time. And the feedstock purity level. You have to look at the feedstock and say, okay, how pure was it? Did the feedstock come in 90% feedstock, 10% water? Which that's why you're not getting your reaction. There's too much water in there. Yes?
On the improper mixing, how do you identify, I don't think we have a problem with too little agitation, but we definitely know slower agitation down at the end of the reaction. So how do we start identifying how to scale it back? Is it just reaction time is what you identify? Yeah,
you can look at the temperature. The temperature you're running at will tell you how long you're going to get maybe 70%. Once you get over 70% conversion, If you can, slow down the agitation, because by then you have a lot of glycerin being made, and it's going to start acting like a surfactant. So it depends on your temperature, and you can do that on a lab scale. All these solutions, if you said, hey, how can I troubleshoot my plant? Do it on a lab scale. You should always take a new feedstock, try it on a lab scale, and say, beat the heck out of it. If you beat the heck out of it for an hour and all of a sudden it turns into a jello, you know something's wrong with it.
I had a question about creating FFAs in the reactor.
Mm-hmm.
Can you describe how that process is happening? So like you take your feedstock, you add your methanol and your catalyst in your reactor, and then you say you could possibly be making FFAs that are then consuming more of that feedstock or catalyst.
Can I put you off for a little bit because the slide's coming up on
Go for it.
addressing that. You could have, one of the other problem areas is poor separation of the biodiesel and glycerin. If your temperature's too high, sometimes it can keep those two, the glycerin and the biodiesel, fairly well mixed. So usually after you're done reacting, temperature starts dropping a little, glycerin's colder, it gets thicker, heavier, sinks, so that's a good way to separate. You can sometimes have an interface between the glycerin and the biodiesel where you have a lot of soap made. That'll act, just like if you want to get oil off your hands, you use soap and water, and it takes the oil off your hands and makes that emulsion layer. So you can have that, too much soap, and that could be due to your high FFA or high water content in your reaction. Sometimes, again, mention the feedstock impurities. Too much shear. That's why I talked about, if you really beat the heck out of it, and it makes tiny droplets out of the glycerin, that tiny droplet of glycerin acts like a surfactant, make an emulsion. So that's why you don't want to have high shear towards the end when you have a lot of glycerin in there. The other thing could be is a improper choice of equipment. People say, should I use a centrifuge, a decanter? Which is the best? It all depends. If you're continuous, you'll almost have to use the centrifuge to keep up with the process. But settling is a great way to go if you're a small producer and you're doing small batches. And it allows you to, sometimes centrifuges can create emulsions in the product because it's spinning at high speeds, and if you have a lot of soap, that could be a problem.
Yeah, that was my question. I mean, we have a glycerin centrifuge.
Mm-hmm.
I'm trying to figure out, is it a better process to use a centrifuge, even if we're not in a hurry, or is it just better to let it settle in cone bottom and separate? What's going to get a better
Do you do batch or continuous?
batch?
Number 2.
Yeah, I would use, if you're doing batch, let it
Just doing
settle.
such large batches that to keep up with it, we kind of have to slow down.
You could use a centrifuge for a rough cut, if you want to do that. Because centrifuges can't separate pure biodiesel from pure glycerin. There's always that interface, and you have to pick, do I want to send some biodiesel with the glycerin, or do I want to send some glycerin with the biodiesel? Because you can never separate it exactly in a centrifuge. Decanter, same problem, but at least you have that interface that you can sort of neck down and maybe get a little better separation. Yes.
Is there any advantage of hydrocyclones over centrifuges?
No, centrifuges are a little bit more controllable than hydrocyclones. But you can, for a rough cut, yeah, you could use it. Just if you use that for separation, either centrifuge or whatever, you want to err on the side of biodiesel going into glycerin. Because it's much easier to get the biodiesel out of the glycerin than it is to get the glycerin out of the biodiesel. Depends on your washing technique too.
Can you slip a coalescer in front of your decanter tank? Solve some of the problems.
Yes.
Simple.
Well, you can. Some coalescers work. It depends. A coalescer a lot of times works in more of a continuous batch instead of a batch operation.
Continuous flowers.
Yeah. So therefore, unless you don't want to tie up your reactor going through a coalescer when you can just go into a settling tank, let it settle, and start another batch. It's a matter of time.
When you mentioned shear, is that from like a centrifugal pump or from sparging? Or?
It could be either. A lot of times you get shear from the centrifuge, but you can also get shear from centrifugal pumps. and we talk about that a little bit later. If your biodiesel doesn't meet specifications, look at your feedstock. Are there impurity levels, high sulfur, phosphorus, or something in there that's going through? Because a lot of times it'll go right through the process in your feedstock into your biodiesel. Glycerin sometimes looks like a sponge. It soaks a lot of the impurities out. So if that's a benefit to us in most impurities in the feedstock. Free fatty acid content, that's always a killer to reactions. Now I've heard a lot of people say, well, let's use corn oil out of the tail end of a ethanol plant. The problem with corn oil is it has waxes in it. You have to take those waxes out. So if you're thinking of using corn oil, consider one, it's high FFA. Also, it has waxes in it you're going to have to remove. And depending on what process, you may want to change your technology process to handle the FFA and corn oil. Yes.
Is that just a cold problem when you've got the waxes in the fuel, or are there other issues?
It's a cold problem. The waxes, you could run the corn oil through the biodiesel process. The waxes tend not to steal too much catalyst. They tend not to make a lot of esters. They end up just being waxes in the final product. But it'll fail the cold flow properties.
And those waxes will end up on filters.
Mm-hmm. Exactly. And I mentioned a couple other oils that you have to be concerned about waxes. If you're using greases and fats, you have to look at the moisture insoluble and some quantifiables. Those are the things that you need to understand. Color bodies. I had some people that were running, what was it? See, hemp makes green. There's a feedstock that made red biodiesel. What is it? Yeah. Well, the problem is if you're making on the road diesel, it shouldn't be dyed, and it looked like dyed biodiesel. So you have to be concerned about the color bodies in there.
I've worked with palm. It's like cherry red when it's done.
And if you're making, if you were in Europe, they use the iodine number primarily to, they have an iodine spec on their biodiesel, which prevents you using soybean oil or palm oil to make biodiesel in Europe. You can only make a certain percentage, and then you have to blend it with rapeseed oil biodiesel.
Would a bleaching method take those color bodies out?
No.
Like with clay bleaching?
Well, it might take some out. Activated carbon might help a little. So yeah, sometimes they distill the biodiesel, and that's how you get the water white.
That actually seems pretty common from what I've heard.
Mm-hmm. Your biodiesel doesn't meet specifications. A lot of times people mismatch equipment. They'll have the wrong size of equipment because they got a special on this centrifuge and it's made to run, 100 gallons a minute, and you're only trying to use 5 gallons a minute. It's not going to work right. So you're going to make sure you have the proper equipment matched for your flow rate throughout the plant. And if you have incomplete reactions, there could be insufficient driving force. That means too little catalyst or too little methanol. And if you have too little, what happened to it? Because if you added the right amount and the excess methanol, where'd it go? Now, sometimes in centrifuges, if you have a two-stage reactor, where you make a batch, run it to the centrifuge, take out the glycerin, then put in another batch, what happens is sometimes the centrifuges have vents on them. And they're spinning and the stuff's hot, you're going to lose a lot of methanol through the centrifuge. People don't realize that. Then they don't add that excess back in the second batch. So then that's where they lost some of the methanol. And again, you could lose catalyst. Catalyst prefers glycerin. So if you do a two-stage or two-stage batch reactor, you have to add additional catalyst to the second stage because most of your catalyst went out with the glycerin.
If you're going to do a two-step process with a centrifuge, you're concerned about losing methanol, would it be, and you wanted to make sure you're getting good separation, would it be advantageous to chill it down before you hit the centrifuge and lose less methanol, get better separation?
You could, but then you have to heat it back up, so you're wasting energy. I'd plug the vent you know, on the centrifuge, and you know it's usually a pretty quick process. Just realize you've lost some, and if you had excess before, it depends on how far your reaction went, you have to add a little excess anyway in the second batch to complete it. So I wouldn't worry about cooling it down.
Okay.
We covered some of these other ones. Too much water is a problem.
Question, for the two-stage, isn't it a little bit better to have a little bit of glycerin even in your second stage to help the reaction? If you're doing like an 80-20?
Yeah, if you're going between the first stage and the second stage, you want to get out the bulk of the glycerin. Now, remember I said a little, if you're going to air with biodiesel going into the glycerin, between two stages the reverse is true. A little bit of glycerin can air in that first stage.
Is that for separation in the end, or?
It's just separation, just to take some of the glycerin off before you go to the second
Yeah,
reactor.
but in the second stage, like, I mean, if you have too much leftover methanol, then it won't be, the density won't be great enough to get separation. So do you want the glycerin in there to aid with that process, or is it part of the?
Well, you're going to make some glycerin in that stage anyway.
Right.
And it doesn't matter because you're going to have to remove the methanol from the biodiesel and the glycerin anyway. So somehow you're going to have to remove it. And a lot of times your wash step will take that out.
Yeah, but like, I'm just saying, like, the glycerin and the methanol are more soluble, so sometimes like,
Mhm.
they'll make a solution that the density is roughly the same as biodiesel, and it won't really separate.
It doesn't absorb that much methanol to change the density that great, so you'll still get separation. Let's see. One of the concerns you have if you have incomplete reaction is that you've allowed the reaction to go in reverse. And how do you do that? Well, there's a couple different ways. What happened is you somehow removed the methanol where there was still glycerin and catalyst in with the biodiesel. And what happens is the reaction goes the other way. If you remember that first slide I showed reaction, it had two arrows. They go both ways. That's why we throw extra methanol in, because we want it to go this way to make biodiesel. If you take excess methanol out, it wants to go back until there's equal amounts. So the key is try to make, you want to keep excess methanol in there whenever you have glycerin and catalyst present. So if you're losing that methanol, because I've heard some people say, okay, after the batch, I'm going to boil off the methanol before I separate the glycerin, just to help with the separation and that. It does happen quicker if the methanol isn't there, but if you drew off the methanol, then you set yourself up for a reverse reaction to take place. You better hope that it settles out quickly and that you get that out and you don't do much agitation, if not any agitation, to keep it so that it settles out quick and you separate them. Yes.
And that reverse reaction doesn't create feedstock again, it creates a whole bunch of FFAs, right?
See, glycerin with biodiesel, it'll create mono and diglycerides. It probably won't create FFA.
Okay.
So if you let it go along long enough, it'll create some triglycerides too. Now, one of the places, if you're using centrifugal pumps, if you're running bare minimum excess methanol and you're running the mixture out of your reactor and going back in the pump, and you get a little bit of cavitation in the pump, that will pull the methanol off, and then you have high shear methanol that's sort of cavitating in the pump. You can get some reversal there. Now, usually if it's cavitating, you're hearing that thing shake and rock and roll and banging and all that, so you're not going to run it very long that way anyway. But just be cognizant of it, that if you don't have enough head pressure, that you can get that cavitation, which can, if it went on long enough, cause enough of it to revert back that you wouldn't meet your specification. We talked about those other two. Now let's talk about if your biodiesel doesn't meet specification. You have inadequate cleaning step. Well, a lot of people may use water washing. Water washing is great in the sense that it does take out the glycerin, it takes out the excess methanol, it takes out the soap. So it's a pretty good product for all around taking out the impurities. Now some people go with the solid catalyst or go with some type of, not a solid catalyst, but like a filter aid. They can use like Magnesol to help clean up their biodiesel. Or they can use sawdust or something along those lines. That'll take out your soap and your impurities. So you have a number of different choices. Try which one works best for you. But if you have so much soap and use too little water, you're going to end up, doing wash after wash after wash, and you're going to go through a lot of water. Now, one thing you can do is you can add acid to break the soap. But the bad part, the negative consequence is that when you add acid to soap, it breaks it in FFA and water. And caustic. So you're going to wash that out, but then you have FFA that loves to stay with the biodiesel. So a lot of times, if you have too much soap and you try to add acid to break the soap, that could be a problem. And some of these solid, products that you can use to run your water, sort of like a solid bead that you can run your biodiesel through to clean it up. Unfortunately, some of those tend to be on the acid side. And so you got to make sure that if you have a lot of soap that it can cause that problem.
Is the big concern there just acid number, or are there other concerns with having free fatty acids in your fuel, even if it passes acid spec?
It's mainly for the acid number. I mean, if you had beautiful conversion and you started out with a pretty good feedstock and you didn't have any water, because water creates free fatty acid, and everything went through great, and you added a little acid because you broke the soap, or you shouldn't have had soap if you had good feedstock, but that little bit of acid would not be a problem as long as it's within spec.
Aren't on the large scale most people adding acid to neutralize the reaction anyway? Which may, if you got any soap, going to do the same thing.
Yeah, that's where you have to be very cognizant of how much soap you have, or how much FFA you started with, how much soap you created. If the rule of thumb is to keep the FFA below 2%, you could almost go to 5%, but then you're going to have a whole bunch of trouble washing. But if you're over 5%, you actually make jello in your reactor. So you don't want to be over 5%.
We've made biodiesel very successfully up to 8%, but our yield has been pretty darn low.
Yeah. Other ways of using, if you have minerals in the water, you should use soft water, not hard water, if you're going to do washing. Ideally, reverse osmosis water or distilled water, but most people you can get by with soft water. Insoluble impurities, water won't take care of the insoluble ones. And if you bubble wash with air, some people will bubble air through the bottom, which takes little bubbles of water up and washes and comes back down. The air can attack the biodiesel and actually start to break it down. So ideally you should use nitrogen. Now a lot of it depends on what feedstock you're using. If you're using soybean oil that has a lot of triple bonds in it, it tends to degrade rather quickly if you bubble air through biodiesel that's made from soybean oil. So if you were using straight soybean oil, I'd say, hey, be aware of that. If you're using some of the other ones that are like animal fats and that are more stable, they're not, they're very saturated. It's not as much of a problem to use air bubbling through. Absorbent additives, you can have that due to poor mixing, because if you add an additive like Magnesol, for example, if you add it in and it's supposed to take out the impurities, here's this particle running around this big mixed tank. It has to come in contact with that impurity in order to grab it and hold on to it and take it out. So if you don't have good enough mixing or long enough mixing, that could be a problem. Your absorbent's not going to do the work. And if you don't have a good filtering system, some of the absorbent will end up in your biodiesel, show up in the ash spec when they do the final analysis. So you want to have enough time to make sure that the you can have that physical contact with the impurity. If you use a resin bed, the problem is you can exhaust the ability of the resin, and then you're not doing the cleaning you think you're doing. A lot of times if you have too much free glycerin, that'll start to block the resin bed and you'll get channeling through the resin bed and it's ineffective. If you have too much soap in resin beds, a lot of times those resins are an acid side resin. They'll break the soap up into free fatty acid, and now all of a sudden you're out of the free fatty acid spec. And also you can get binding of the resin. If you had soap, a lot of times it'll go in there and it'll look like snot on top. And all of a sudden it's binding up that resin and it's inactive. So there's things you have to be concerned about if you use resins.
And if you're using like kind of the cheap type of resins like wood chips or whatever,
Mhm.
you have to watch out for mildew that can happen in there. If they get loaded up on too much water, I've seen the oak chips turn black before, and that can start to cause problems.
Yes. And some people use the wood chips or whatever as a precursor before they use their expensive resin as a polishing step.
Yeah, we actually use it in a column as a polish after our water wash.
Okay. The other thing
Or
about
after the dehydration after our water wash.
there are resins that can take out some free fatty acid. So if you had a batch that was just barely out of spec, sometimes you can bring it back with special resins. It'll take out some of the free fatty acid. Did you have a question? Yes.
How do you make sure you don't have too much free glycerin going through like your amberlite or pedalite that you're using? Is that just really with your settling process, you gotta make sure it's...
Yeah, that's why I said when you're doing your final settling, let a little biodiesel go in with your glycerin as opposed to the glycerin with the biodiesel. Some common problem sources: feedstock, your plant design. Make sure it's designed to run the feedstocks that you want to do. The order that you do the processing is important. Sometimes, like we mentioned, if you take the methanol out before you separate the glycerin and biodiesel, that could be a problem. And operator knowledge. You know, a lot of times people don't understand the process. Get in the lab, make these small little batches, make mistakes. When we taught our workshop, we would actually teach, have you make a batch with too little methanol, or too much catalyst, or too little this, or too little that. And it always turned out terrible, but at least people got to see what happens. And then when they get back and run their own plant and they see the same thing happen, they know, oh, I know what I did wrong here. As far as our alternative feedstocks, biodiesel production strategy, you want to make sure that when you get another feedstock, it sometimes has to go some additional processing. Do you want to do the processing up front in the front of your plant, or who you're buying the oil from? For example, if you're going to buy yellow grease, you can buy yellow grease and specify, I want it under 0.5 or 500 points moisture, parts per million moisture, so that you don't have to dry it when you get it. If you can shove some of it off on them, they'll do it, and if they have the equipment and it's a normal process, fine, no problem. They'll do it. But if you're collecting your own oil, then you're probably going to have to do those processes in-house. Do you want to pre-treat the feedstock first, or do you want to polish and take care of the impurities in the final biodiesel product? That's a decision you have to make. Do you have the equipment to do either one? But most of the time, it's easier to take the impurities out front, out of your feedstock. For example, you wouldn't want to run French fries through your process and have to take them out in the final biodiesel, because by then they're broken up and it's going to be a lot harder to remove. And sometimes you can use a combination of strategies. Do a little cleaning up front. That's going to save a lot of headache from the tail end, and then do the rest on the tail end. The question with the corn oil: do you want to take the wax out front, or do you want to take the wax out the end? If you have to cool down your batch at the end to take out the sterile glucosides, why not take the wax out then too? Why cool it down twice? So that's that's where you can use your strategies depending on what feedstock you're running. And you have to look at, if I can get a real cheap feedstock, what's it going to cost me to produce? Is it going to be more expensive to produce? I might as well just go ahead and buy white grease which doesn't have any FFA. Sometimes you can buy white grease for the same price as yellow grease, and it has no FFA. So buy the white grease. So, you know, you have to look at the cost of the product versus what's coming out the tail end. Some pretreatment technologies. There's chemical methods. You can use caustic to remove FFA. You know, sometimes if you have a high FFA feedstock, you can add caustic to it, which then forms soap, separate the soap out then, and then use that feedstock to go on. That's how the soybean oil processors do it. That's how they remove the FFA from the soybean oil as they process it. You can use acid catalysis or esterification, so you can run your free fatty acid through and use acid to convert it to biodiesel, neutralize the acid and go into a trans-esterification process and convert the rest of the triglycerides to biodiesel. So that's a good way to, you know, be able to use high FFA feedstocks and still go through your reaction. You can use solid catalyst. That's an upcoming thing, but you have to understand solid catalyst, when you want to go with different feedstocks and that, sometimes they get poisoned by metals. And so therefore, a solid catalyst, you want to make sure that you can continue to use it. If it ends up getting poisoned, it's useless, then you've thrown a lot of money away on a solid catalyst. And sometimes they have very stringent feedstock requirements. Glycerolysis. Now those, you know, if you're going to run straight corn oil, then you'd probably not go with acid esterification. You could probably go with glycerolysis. What that is you add glycerin to your high free fatty acid material, react the two, and that makes mono and diglycerides. So actually you're forcing the reverse reaction where the glycerin combines with the free fatty acid, makes mono and diglycerides. Then you put that whole thing through your trans-esterification process. No soap's made. It's in great shape.
What's your glycerin like after that when you separate it in the transterification? Still the same?
It's probably cleaner, a lot cleaner, because you took all the FFA out. The bad part is the glycerin that you have to use in the, you know, with the FFA. That's usually a higher temperature process, and so you usually have to have a hot oil heater. Yeah, but if your plant already needs high temperatures for whatever the reaction way you're going, then this isn't just another step.
At our plant, we take the glycerin from the back end, put it in for an upfront glycerin pre-treat, and it does some degumming, I think. It lowers the FFA, and I don't recall exact, I think it's because there's methanol entrained in it, it lowers the amount of methanol we have to use in the
Okay.
reaction. So it's kind of like a dirty version of what you were describing.
If you're using a two-batch operation, the glycerin coming out of your first batch is real dirty. It has all the impurities, it has most of your soap, because already you've converted the FFA to soap, pulled out most of your soap. The glycerin out of the second stage is a lot purer. It's mainly catalyst, methanol, and glycerin. So a lot of people will take that glycerin, run it around on the next batch, put that in, and that'll help strip out, and again, the catalyst that was in there will attack the FFA and make soaps again. So yeah, that is a very, you know.
I'm not sure if we're only doing it with the second stage glycerin, but perhaps we should be. I'll look into
Yeah,
that.
because it's a lot cleaner than the first stage glycerin. There's enzymatic. That's constantly being looked at as a new way of going. Usually it's still more expensive, and it's also great for making specific type biodiesel or byproducts. And other chemical methods, you can do some degumming operation if you have a feedstock with a lot of gums. Some separation methods is centrifuges, absorbents, resins, molecular sieves. Some places are using that to purify the methanol. You can use chilling to take out the waxes and improve the cold flow properties of your biodiesel. Carbon treatment for color and other impurities. Distillation to purify your methanol and or your biodiesel. You can flash evaporation. That's at least you should do that. That'll take the methanol off the biodiesel. very simple, easy method. In fact, I don't know if you guys know Leaf Rapids at Piedmont, but I talked to him on the phone when I was driving from Dubuque to Ames and described how he could build a flash evaporator for his plant many years ago. You can use gravity settling, filtration, and water washing. How to correct a bad batch? Before I get into this, I want to answer your question about how water and how FFA can be created in the reactor. Basically, when water's mixes with the triglyceride, it can attack the triglyceride, break off a free fatty acid, and basically make a mono or diglyceride. So that's what too much water at high temperatures will do.
So if in the reactor, but what if it's already mixed with the methanol and the catalyst? Would it not just make soap, or will it actually make
It can,
an FFA and then make soap?
yeah, FFA then soap. And if you look at it, when I say look at the water content going in, you may say to me, oh, well, my feedstock coming in is only 0.5% moisture. I'm well within the limits. But then you're adding methoxide that you made, methanol, and you added potassium hydroxide. That creates about 0.3% moisture. So that's in there. So you're adding it with that. And if you're adding methanol that you didn't take back up to 99 or 98% purity, if it's only 95, there's another 5% water. Now all of a sudden you have 2,000 parts per million of water going in. That's a lot of water. That's going to inhibit the reaction. It's going to make FFAs, take out your catalyst. So that's where a lot of the problems come from. I had a plant that was running in Kentucky that called me up and says, hey, we're getting a whole bunch of soap being made. I said, well, what feedstock are you using? He says, well, we were using degummed soybean oil, but we just switched to vegetable oil. I says, how much moisture is in your vegetable oil? Oh, well, it's got quite a bit of water in it. I said, okay, what's about free fatty acid? And it turned out that he was actually bringing so much water in with his feedstock, and he wasn't distilling his methanol as good as he should have been. So he had a problem. He was bringing too much water in. That's where all soap was. So I gave him do this, 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 and this, and you'll be okay. He did them. He was okay then. So
looking at FFA going in might not be actually the FFA that's in the reactor because you're creating FFA.
Yeah.
So I think that's what's going on at my plant is we're running 2% FFA, but we're getting a ton of soap. So I'm thinking the moisture from various places is built up. And
take a look. If you're making your own methoxide, that's a problem. I did a calculation for a plant because one time they said, hey, I can buy sodium hydroxide and make my own so much cheaper than buying methoxide. I said, okay, let's do the calculation. So I calculated it out. I calculated how much water they made and everything. I says, it was like 2 cent difference. I said, for 2 cents, you're adding this much more water, which is causing you more soap. Do you really want to do that? And so he started buying methoxide. And now that we have plants in the United States that are making it, it's fairly cheap. Now, if you want potassium methoxide, that is a lot more difficult. Not everybody makes it.
I want potassium methylate so badly. It's impossible to get.
The only thing is, if you make it, yes.
5 minutes.
Okay.
I have a question.
Sure.
In the process, when the water is created and the reaction has stopped and you have a problem, how do you dewater it at that stage?
Say it again.
If water is the problem.
Yeah.
Creation of water is the problem. How do you get the water out at that point?
If it's already in your reactor, if you've already added your methanol and your methoxide, it's pretty hard to get it out at that point because methanol is going to boil off first, and then you could take it up to a high enough temperature, boil off your methanol, boil off your water, but you still have the catalyst in there, which is going to start attacking the biodiesel, and catalyst and biodiesel will create a bunch of, it'll break up that triglyceride and cause you problems too. So I would say at that point, go through and delve with the soap.
Are there
But-
membranes that might be able to help with that?
There are some work being done with membranes that might be able to take some of the water out, but methanol can sometimes slip through too.
So what's your water guideline going into a base reaction? What do you want it to be less than?
500 parts per million total.
So there was a
That's
discussion.
0.05%, right?
Mm-hmm.
There was a discussion earlier that there's kind of a trade-off between your initial titration for FFA and the acceptable BPM for water, where if you titrate lower initially, then it's possibly acceptable to have more water in your oil. Do you have any feelings about a balance between the two there?
You want to try to still keep, yeah, I mean, you can play that number because you know the FFA when it reacts will make water and that's going to add to that other water. As long as you keep it under that 0.5, then you should be okay. Just go through this quick list. You can read through it. Here's if you have too high free glycerin in your final product. These are all the steps that you could sort of address. Too high water content, flash evaporator or settle. Water will settle out of biodiesel. Too high flash point. It's probably because you still have biodiesel in there. I mean methanol in there. So you have to get that out. I have to throw in a plug for this. You know, this is a book that we used for our workshop. I have copies out here if anybody's interested in them. It's everything from A to Z on biodiesel. It talks about what goes on in a diesel engine, why it works, the chemistry, also all the processes, EPA regulations, and then my contact information. Any other questions?
I just want to give you another plug for the technical side. Biodiesel Handbook is also really good.
Yes, but we're a lot cheaper. Yeah. Yes.
I just have a concern with our plant, you know, as we're expanding to new feedstock suppliers, that I'm gonna run into issues with getting too much water in my WVO.
Mm-hmm.
I mean, but we don't really have money to build a whole new flash column on the front end, so we have a flash column on the back end. I mean, just heating oil up, is it gonna do enough to reduce that parts per million on our water content if I recirculate it and heat it? I mean, what's the
Yeah, if
best
you heat it
option?
up and you let it settle and sit long enough, the water will set to the bottom. But since there's water in it, it's also going to increase the FFA the longer you hold that feedstock.
Again, heating plus running it through a coalescer and then
Yeah.
circulating.
So is there any like affordable options, I guess, for?
The coalescer is a cheaper way to go. You can make them yourself.
Well, and vacuum dehydrators have coalescers, and I have two of them. One's kind of back up on the back end. I'm thinking of moving it to the front end because we've never targeted 500 parts per million on the front end, but
Mhm.
I like that idea.
What have you used in the past?
We just use decanting with heat, and it does take a while, and I'm sure our FFA goes up during that process.